Continuing on in Unit 4 with chemical reactions and quantities, and now that we're doing full stoichiometry problems, it literally is everything in the Unit 4 title, Chemical Reactions and Quantities. So let's try it out. If the entire front bumper of my 1996 Chevy Silverado rusted off and produced 2.6 times 10 to the 6 grams of iron oxide, how many grams of iron were originally in the bumper? So, the reaction. The iron 3 oxide, better known as rust, is produced. Iron has to be present in it originally. The only thing not given to us is always given to us when something rusts or is exposed to the air. So we need to balance it. The next thing we should probably do is identify our givens and our wants. We are given grams or a mass of iron 3 oxide. We want to find grams of iron. So when it comes to looking at the chemical reaction, I do not need to know the molar mass of iron. Of oxygen. Okay? So the molar mass of oxygen is not necessary. Easy to find, but not necessary. I'm only going to find the parts that are underlined. I now have to resize it a little bit so that I can have some room to do some calculations. The molar mass of iron is easy because all I have to do is look on my periodic table for the molar mass of iron to be 55.85. It's not a very good 5 right there, so I'll try to erase. Oops. I then need the molar mass of iron 3 oxide. Oops. Wrote what I was saying. To do that will require me to know how many of each element I have present in the formula, finding the molar mass using my calculator and my periodic table. Kind of ran out of a little room there. Let's rearrange some things.
Okay, hold on. Why didn't you round the 15.99?
I'm going to resize some things here. I think it's just going to make life easier for me. Yeah, Peterson's making his own life easier. What a novel idea. So we'll resize some things. I just like it orderly. I know it's weird. Why would somebody want to have some order? Is it gonna work? Yes. Sweet. Okay. Now that I have that, I can do the multiplication. Times 2 87.97. Add those together to give me 159.67 grams per mole. All right, so let's do the whole problem. We have to start with what we're given, as always. 2.6 times 10 to the 6th grams of iron 3 oxide. We now use items that we've calculated. Technically should have my labels in here. Okay. My labels for grams of iron 3 oxide cancel out. I'm now at that point where I go moles of one thing to moles of another. So now we have to use the balanced chemical reaction and the numbers that are associated there. Yep, I know. So the numbers that are associated with that, and that would be, I want to get rid of moles of iron 3 oxide, and I want moles of iron. This one is different than we've done before, in that we actually have numbers to put in there. So, because here's the other part that usually students don't have the issue with. We end up putting everything into our calculator. So 2.6 times 10 to the 6th times 4 times 55.85 divided by 159.67 times 2. And you get a very large number.
Where's that word equation? Answer the bird.
And you get 1.82 times 10 to the 6th grams of iron.